This video will demonstrate how to find the pH of a weak acid or base, and in this case we're specifically using dimethylamine. We have the initial concentration here, we have an equilibrium constant, Kb, and we have the reaction of dimethylamine with water. So the only thing left to get this started is to write out our ice table for the initial concentration, the change in concentration, and what we expect our concentration to be at equilibrium. So we start out with 0.1 molar in our dimethylamine. We don't have to worry about water because it will not be participating in the equilibrium. And we have no common ions to worry about as well. So everything is 1 to 1, so minus x here, plus x for our ions. And the equilibrium amount is going to be just the sum of these two lines. So now we can write out the Kb expression, substituting in for our ions here, and then substituting in the dimethylamine on the bottom. Now, by the approximation method, we're able to neglect the effect of the change in our overall concentration of dimethylamine. And this gives us 4.79 times 10 to the negative 4 will be equal to x squared over 1 times 10 to the minus 1. So this gives us the result that 4.79 times 10 to the minus 5 is equal to x squared. We can take the square root of this, and we find that we have 6.92 times 10 to the negative 3 as our value of x. This value arises out of the approximation method, so in order to verify that we can proceed, we want to check this against the 5% rule. So we take the amount that we have from our solution, 6.92 times 10 to the negative 3, and divide that by the initial amount, 1 times 10 to the negative 1. This gives us a result of 6.92 times 10 to the negative 2, or 6.92%. Because the amount we solve for by approximation is greater than 5%, this is a fail. So we'll have to use the quadratic formula, and while I won't go into all of the details of writing everything out, I will write the actual formula itself. 4.79 times 10 to the minus 5 minus 4.79 times 10 to the negative 4x minus x squared equals 0. So we can pull values for a, b, and c and plug that into the quadratic formula. And what we find for the one answer that actually works is that our hydroxide ion concentration will be 6.69 times 10 to the negative 3. So since this is our hydroxide concentration, we can quickly find pOH by taking the negative log of this quantity. We find that that is 2.17. And because pH plus pOH equals 14, it is straightforward to determine the pH of this. And we have 11.83 for our pH value. So we have to take the additional step of using the quadratic formula because when we compare against the 5% rule, the answer we get out of approximation is larger than 5%. Once we've gone back and found the true value of x, we can determine a pH value, which we have here as 11.83.